Hello, everybody. How are you guys doing?
Oh, good.
Good,
I'm
thanks.
good.
Okay, so we'll go ahead and get started. Um, so here's the practice. I posted it. When did I post it? Last week sometime. So I might have given this spiel to you already, but I took the questions from the midterm and rewrote them like in the same, like the sentence looks exactly like this. I just changed the numbers. Okay. So like number two, they talk about pH of a urine sample. I took the same thing, I just changed the pH. Okay. Um, so your test is 50 questions, and I have, let's see, how many questions do I have written here? 45. So we basically we'll cover everything. The exception is, where do I have it? Like 32 here. This practice question covers two questions for us. Um, where's another one? Oh yeah, and then here's the other one. Naming ionic and covalent compounds. There's like four questions about that. So that should bring us up to 50. Um, let's see, who has their Jasmine?
Hello. Yeah, can you hear me?
Yeah.
Now I know we had this. I didn't hear you when you first came on, but I know we have the study guide. So should we focus on this right here or the study guide?
It's up to your preference. They're both the same information. Like the study guide just wrote like statements like be able to do this, and then this is like actual questions, practice questions.
Okay, thank you.
Mhm. All right, you want to get into it? So, what is the hydroxide? Oh, something else. But actually, before we start, so your formula sheet that I'm going to give you looks like this. All right, so we have gas laws and then that conversion. We have temperature, just a reminder of big M, Avogadro's number, common prefixes, the acids and bases stuff. But I also have that same acid base square over here. We have the prefixes for covalent compounds, the stoichiometry chart, and then this has been the molecular weight thing I've been referencing. And then this just periodic table. But you guys are allowed to bring your own periodic table that you have written notes on. Front and back side's fine. Um, I'm gonna try to print it in color, but I doubt I will have access to a color printer. So, if you prefer to have your stuff in color, I can post this, but yeah. Okay, so the first question has to do with the pH acid base stuff that we learned. All right, so it says, what is the hydroxide ion concentration of a solution whose H plus or H3O plus is 1.0 times 10 to the negative 10th, okay? So hydroxide is OH, all right? And then here, this is the same as H plus, H3O plus. So if we wanted to reference our acid base square here, we want to go from H plus to OH. I wonder if I can turn this. Let's see. Okay, I don't immediately see how to turn it off the top of my head here, but we want to use this formula, the KW formula, 1.0 times 10 to the negative 14th times or equals the concentration of H plus times OH. Okay, so 1.0 times 10 to the negative 14th equals the concentration of H plus, or I'm sorry, OH times H plus. All right, so I have the concentration of this. I can plug that in here. To get OH by itself, I'll divide each side by H plus. All right, so in my calculator, I'm doing 1.0 times 10 to the negative 14 divided by H plus 1.0 times 10 to the negative 10. All right, that's what I'm plugging into my calculator. Making sure I'm using parentheses or else stuff will get lost. And when I do this, I got 1.0 times 10 to the negative fourth big M. All right. Any questions? All right, I'll keep going along. So here, the second question, if the pH of a urine sample is 3.34, what is the OH of the sample? So going back to my acid-base square, really wish I figure out how to turn this. I know there should be a way, right? Okay, it's not, okay, stop. All right, so now I'm given pH and I want to go to OH minus. So I have two options. I can go around the square two different ways. I personally would prefer this way. I like to use the way that has this formula over this formula. It's just less messy, I think, and less chance for mistakes. So I'm going to have a two-stepper. The first step, I'm going to use the formula pH plus POH equals 14. The second step, I'm going to use the 10 to the negative POH formula. Okay. All right, so first step, pH plus POH equals 14. So I have pH. I want to know the POH. Fourteen minus 3.34. Oh. So here, first step, I got my POH equals 10.66. All right. Second step now, I want to use OH equals 10 to the negative POH. All right, so I have my POH solved for in the first step here, 10.66. So I plug that into my calculator, making sure to put the negative 10.66 in the exponent. And I got this. I can round it. And so your test is going to be multiple choice, so you would just be looking for this answer in one of the answer choices. All right, number 3, again, same wording as the test. So a client with respiratory alkalosis has an H3O plus concentration of, and then I changed the number, 5.76 times 10 to the negative 4. What is the pH? So we're trying to go from H plus to pH. All right, so we'll go back to our formula sheet. All right, so H plus to pH. I already forgot. I'm pretty sure it's this though. All right, so now we're doing pH equals the negative log of H plus. pH equals the negative log of H plus. All right, so I plug in negative log 5.76 times 10 to the negative fourth. Put that into my calculator. Negative log 5.76 times 10 to the negative fourth. And I got a pH of 3.24. This one's only a one-stepper. Any questions? Okay. 4, what term best describes a solution with a pH of 3?
Acidic.
Acidic, yay, somebody's talking, yay. Okay, acidic, yep. So 0 to 6.99, acidic, 7 on the dot, neutral. I always write this wrong because 7.01 to 14, basic or alkaline, those are the same. Alkaline. I don't think I spelled that right. Yeah, I forgot now. Okay. Okay. 5. Okay. What is the formula of the conjugate base of HCl? So they want to know what they're not explicitly telling us that it's an acid, but they're saying what is HCl plus whatever going to look like on the other side. I shouldn't have used A, that's misleading. Let's just say X. Gonna look like on the other side, right? As in its conjugate base form. Okay. So if we're looking for if something's in its conjugate base form, we must be acting as the acid on the other side. Okay. So if we're acting as the acid, we're going to give up our hydrogen. Okay. So its conjugate base, I should write this in my, is Cl. Okay. Because it's lost that hydrogen. It also becomes Cl minus because hydrogens have a positive charge. So if we have HCl, which is neutral, and then all of a sudden I take away a positive from it, there's going to be a negative there. I wouldn't stress too hard about like knowing the positive negatives. If you're able to identify Cl and then you see a charge with it, then now just go on. Choose that answer because remember it's multiple choice. Another example here, we have HCO3 minus. So I like this example. Okay, so we have plus X yields what? Plus a Y, right? So again, same idea. If it's acting as the conjugate base, then it must be acting as the acid on this side. So an acid, it's going to lose a hydrogen. So when it loses a hydrogen in this example, it became 2 minus because it was already 1 minus. Yeah. Any questions?
Can you do another example?
Let's see. We can do, I'm gonna keep sticking with the conjugate base route just because that's the example you're gonna see on the test. I'm just changing the element. So let's do HF. We could do HNO3. All right, so HF, if it's acting as the acid, and we're looking for the conjugate base, we want it to lose a hydrogen. All right, so it's gonna become FS, or sorry, HF is gonna become F minus. All right. HNO3, again, we want it to lose a hydrogen, so it's become NO3 minus. Does that help?
I'm
Yeah,
confused. A little bit, but I just want to know. Wait, what was my question? Oh my goodness, I lost my train of thought.
That's okay.
so is the so is the like so the F negative, is that always going to be negative?
Yes.
Okay.
Okay. The one below it, for some reason, all the arrows in this document got changed to question marks. But number 6, we want to determine. Okay, so I wrote determine the Bronsted base on the reaction side, because remember, this is going to be a multiple choice question. So you would have, maybe A is H2SO4, B is H2O, H3O plus, right? But I think just for the sake of it, we're going to go through and identify them all. So acids, they give up hydrogens as they cross the reaction arrow. So the first step I do is I look for uh, what's the same on both sides, kind of like what's their partner, right? What looks the most similar? So to me, H2SO4 looks similar to H2SO4 minus. Okay. H2O looks similar to H3O plus. Okay. So we want to determine the acid. He's going to be the one that gives up the hydrogen. Bases accept hydrogen as they cross the reaction arrow. All right, so H2O4 became H2SO4 became HSO4. So it lost a hydrogen. It gave up a hydrogen. So it's acting as an acid. H2O gained a hydrogen or accept a hydrogen. So it's acting as a base. All right. So the question asked to determine the base. So in this, if this was our answer choices, A, B, C, D, right, I would be choosing the one that was water, B.
See, now that one was easy to understand.
The number 5 is a little weird, but you only have to do it once, and you're just dropping the hydrogen.
Okay.
All right. I know you can technically still, yeah, we'll just do 7 before I move on. Scroll up. Okay. So calculate the weight, volume, and units of grams per mil of a solution prepared by dissolving 2.13 grams of sodium chloride in enough water to give 0.34 liters. Okay. So percent weight volume. I honestly can't remember. I'm sure this is on the reference sheet. Maybe it's not. I should add that. All right, so it's grams per mil times 100. All right, so the formula, grams over mils times 100. All right, so here, this is nice because we're already given grams, we're already given, oh wait, we're not given mils. I lied. We're given liters. Okay, well that's okay. We're given grams, we just need to figure out liters, okay? So we need to go from liters to milliliters. This I do know is on the reference sheet. So here we go, right here in parentheses, 1,000 milliliters equals 1 liter. Okay. Um, okay. So we'll set it up. like like all of our other problems here. So we want liters on the bottom so they cancel, milliliters on top. 1,000 milliliters equals 1 liter. So 0.34 times 1,000. 0.34 times 1,000 is 340 milliliters. All right, so now I have grams and milliliters. Now I can plug it into the equation. All right, so I can do 2.13 over 340 times 100. All right, and I can plug this into my calculator. Huh, I got less than 1%, but that's probably because I made the numbers weird. I just made them up. I didn't double check them. You're probably not going to get less than 1%, but like I said, I didn't check the numbers. All right, any questions on this first page? All right, take any photos, screenshots, whatever. Okay. I left some writing on here from the last time. All right. Number 8, a normal saline solution used for IV drips contains, made this number up. Do not tell patients or or your work or anything. Made this number up. But 1.12 grams of NaCl per 7 liters of solution. What is the molarity? All right, so if you forget what the heck molarity is, it is here. Moles over liters.
Do we have that reference sheet somewhere in our documents, or is that yours?
I haven't posted it yet, but I can post it tonight.
That would be freaking awesome. Thank you.
Yeah, I meant to post
Like,
it.
I'm writing all the ones down that I'm learning, but I just want to make sure I'm getting all of the ones that I need.
Yeah.
I probably have more than I need, but
Okay, so moles over liters. When I got to this problem, I knew that was asking me for molarity, so I'm using big M. All right, so here's the thing. Just like the last problem, I have one of the units sorted out. I have liters, but I'm not in moles. But I can go from grams to moles using the molar mass, okay? I already have it over here. The molar mass is 58.44, but like I said, I've been talking about this reference sheet, how it's going to have a box here. So I have, you just got to look for it, NaCl, 58.44, right? That's where I got that. Here we go. Okay. So we gotta, first we gotta go from grams to moles, and then we can plug it into the actual moles over liters formula. Okay, so first step, grams to moles, so 1.12 grams. So now I want grams on bottom because I want them to cancel, moles on top. The number is married to the gram, so since I put grams on bottom, I'm going to put the number on bottom. So because the number is on bottom, I'm going to divide 1.12 divided by 58.44. I got this. Gonna round it. All right, so now I have my moles and my liters, so now I can plug it in. All right, so big M equals my moles I just solved for over my liters. And then I just got to divide that. Two. All right, and that's what I got when I plugged it into my calculator. Number 9. All right, so a gas mixture of neon and argon has a total pressure of 1.7 atmospheres. The partial pressure of neon is 0.89. Calculate the partial pressure. All right, so partial pressure. Of course, there's a formula for everything. So partial pressure is up here in the gas pressures. So it just says the total, it has 3 things right in here, but the total pressure is equal to the sum of all the partial pressures of all the individual gases. So the total would be equal to the pressure of neon plus the pressure of argon. Right? And if there's more gases, we would just continue that, but there's only 2. So we know that the total is 1.7. We know that neon is 0.89. We want to solve for what argon is, so I'm going to subtract 0.89 from each side. I got 1.7 minus 0.89, 0.81 for argon. All right. Number 10. All right, so I see a lot of numbers, but I see the word diluted twice. So I know that this is the dilution equation. All right, so we just recently, dilution equation came from lecture 3. Actually, all this stuff might have came from the last lecture so far. Yeah, all this came from the last lecture. All right, so the dilution equation, so we'll go back to our reference sheet, show you where I'm getting all this. Dilution equation. Oh my gosh. Do I need to add the dilution equation too? I need to edit this reference sheet before I post it. It's kind of a good thing that I'm going through this. Okay, so well, it would go under solutions. So the dilution equation is C1V1. I shouldn't write it equals like that. C1V1 equals C2V2. All right, so this equation is basically proportion. So it doesn't matter which units you use for concentration as long as they're the same on both sides. Same thing for volume. Doesn't matter the units as long as they're the same on both sides. So we have C1V1 equals C2V2. Okay, so I'm going to make myself a little key over here so I can keep track of all my variables. So student dilutes, so here's my initial volume, 34.5 mils of 2.75 nitric acid. That's my starting concentration. All right, and to a total volume of 300, so this must be my final volume. And then I'm trying to figure out what the final concentration is. So since we're solving for C2 and our first concentration was in molar, then it's just going to come out in molar. But I need to make sure my volumes are the same unit, and they are. They're both in milliliters. So I'm good to go to plug this into the equation. So I got 2.75 times 34.5 equals X times 300. All right, so with the dilution equation, right, we want the solution to be diluted, so the concentration has to be less than what we started with. So we started with 2.75, so I'm looking for a number that's less than that. All right, so to get X by itself, we'll divide each side by 300. I'll plug this into my calculator, 2.75 times 50, 30, yeah. All right, I got X equals 0.3 2 molar, which is great. That is less than 2.5, so that's great. All right, number 11. Okay, so a 3.5 mole sample of gas is confined in a 6.75 liter tank at a temperature of 25 degrees Celsius. What is the pressure? Okay, I see a lot going on here. Here's the thing. You're only going to be asked about 2 different gas laws, or you're going to be asked to change the unit. All right? So this has got a lot going on, and it's cueing me that it's probably the other gas law we learned about, which was ideal gas law up here. All right? So PV equals nRT, where R is this value. Okay? So PV equals nRT. Just a reminder, R is going to equal this. All right, so just like the other one, I like to come over to the side and just list all my variables. P, it looks like that's what we're solving for. We need it to be in atmospheres. V, 6.75 liters. N is moles, 3.45 moles. Temperature is 25 degrees Celsius. Okay, so this formula has specific units, okay? Pressure has to be in atmospheres, volume has to be in liters, N has to be in moles, and then temperature has to be in Kelvin. All right, and if you forget that, if you go back to the formula sheet, all right, that's all these units here, okay? So liters were good, atmospheres were good, moles were good. We're not in Kelvin though, we're in Celsius. So to go from Kelvin to Celsius, we'll need to use this formula where we're going to add 273 to what we have basically. So plus 273 is 298 Kelvin. All right, so now I'm good to go and plug it in. All right, so we got P, that's my X, V 6.75, N 3.45, R this weird value, C 298. All right, and solve for X. Plug the rest of this into my calculator. All right, and then I got 12.5 atmospheres. All right, any questions? All right, so number 12 is talking about gas stuff again. But we're just, or gas pressure, we're just changing the unit. So a client has a systolic blood pressure of 345 millimeters mercury, and we want to express this unit in atmospheres. I already left this over from when I was erasing the document from the last time I did this, but where I got this, the reference sheet, okay, under the gas laws. So just like we've done any other unit conversion, I'm going to start with my given on top. I'm going to put millimeters mercury on bottom because I want them to cancel, which leaves me with atmospheres on top. Looks like there's 1 atmosphere for every 760 millimeters mercury. So now I just need to divide 345 divided by 760. I get a little less than half. Right. Number 13. All right, so we got this is stoichiometry and 14 is stoichiometry. How did I know that? Okay. So first of all, I see a balanced equation already there. All right, so that's a cue that it's stoichiometry. And it looks like I need to determine how many grams of iron are produced from 4 mils of chlorine, 4 moles, right? I'm switching units, or sorry, substances, switching units and substances. All right, so that's a key to also stoichiometry. Okay, so on the reference sheet, I have the diagram over here. So we're starting in moles of, I can't remember if it's a reactant or a product, but the steps are going to be the same, okay? So let's say we're starting here. So we're starting in moles. We're going to have, and we want to end in grams of the product or another substance. All right, so we have 2 steps we need to do here. First step is we need to switch substances using the mole to mole ratio. These are the coefficients from the balanced equation, okay? And then our second step would be to go from moles to grams using the molar mass. Okay. All right, so I'm gonna start with what I'm given. On top, 4 moles of CO2. I'm gonna do that first step, the moles to moles. So I'm gonna put moles of CO2, Cl. Whoops. Moles of Cl2, yeah, chlorine on bottom, moles of iron on top. All right, so there's 2 moles of iron for every 3 moles of Cl2. All right, so now I'm out of moles of Cl and I'm in moles of iron. That's not quite where I want to end though. I still need to go to grams. So I'm going to put moles of iron on bottom and grams of iron on top. All right, so now I need the molar mass. Because this isn't a molar mass of a compound, it's really just iron, so you can just go to the periodic table. So iron Fe, where are you? Here we are. 58 or 55.85. All right, so grams 55.85 per 1 mole. All right, so now I'm out of moles and I'm into grams and I can plug and chug into my calculator. So how I personally type it, I would do 4 times 2 times 58 or 55.85 divided by 3, then equals. All right, so I got 148.93 grams of iron. All right, any questions on this page?
Don't move it yet.
Okay, thank you.
I think where I get confused at is trying to remember what formula go with what equation. Like, I don't know, it just seems like it's so many. And just
Yeah,
trying to remember which equation is for what formula.
okay. So let's start from the top. Okay, so anytime you see like OH, H plus, pH, pOH, I'm looking at the acid-base square on the formula sheet, okay? So all of these had to do with the acid-base square. That's what I was referencing. Here, it was specifically looking for this guy. I need to add this to the reference sheet, but that's how I knew to go to the formula for that. 4, 5, 6 didn't need formula. Molarity, right? The only time we are going to use molarity is when we're solving for it. So that's how I knew to go to the molarity formula on the reference sheet. Partial pressure. That's how I need to go to the partial pressure law. Here, this one, dilution equation. The word dilutes was twice in here twice. Dilutes, diluted.
So we
This
basically
one,
go by the wording.
yeah.
Okay.
This one I don't really have a great, because honestly, when we were doing number 10, I kept looking at this one and thinking, oh my God, what is that problem? And then I just remembered like lots of different variables, and you're like, how the heck am I going to connect all these variables? Then I remembered it was the ideal gas law. The ideal gas law has just like a lot of different stuff going on. This was just changing, yeah, unit just said to express this pressure and the different unit. Yep. So, okay, and then stoichiometry here. It's for me, the dead giveaway is the already balanced equation in the problem. Because there's just no other type of problem that's going to give you that.
So we're gonna have that formula sheet.
Yeah, I'm gonna make some edits, but I'm hope to post it tonight. I put it on my to-do list.
Okay.
For 13, I got 1.488.
1.488. Oh
Yeah.
yeah. Maybe I thumbed something wrong.
Times 10 to the second power. Unless I did it wrong.
Oh, I bet your calculator is still in scientific mode.
I'm pretty sure it is because I didn't know how to change it back.
Let's see. Quisha, I'm pretty sure you had the one where you hit mode and then you push down a couple lines and then you go over to norm and click enter, but then you have to click clear.
Okay, I got it. Thank you.
Yep. All right, any other questions about this page? All right, we'll keep going. Keep going. All right. So 14, another stoichiometry one, and like I said, the giveaway is the already balanced equation. All right. So here we want to determine how many moles of FeCl3 are produced, and they give me moles of chlorine again. Okay. So this one's just a one-stepper. It's basically, we're just doing the first step that we did in this last one and stopping there because that's the unit they want. All right. So I can start with my given equation, 4.35, or given, yeah, whatever, our given, right? 0.35 moles. But moles of Cl2 on bottom. This time, instead of going to iron, it looks like we're going to this guy, FeCl3. But the process is still the same, right? I want to cancel out my moles. I'm going to get the numbers that I use from the balanced equation. So this time I need to make sure I put 2 here because that's the coefficient for that. 3 on bottom. Right? And so now I'm into moles of FeCl3, which is what I want my desired units to be. So I'm going to do 0.35 times 2. So that's 0.7 divided by 3. 0.23 moles of iron chloride. All right, 15 balance equations. I'm pretty sure you have 2 balancing equations. Did I not put another one on here? Doesn't look like it. I'm pretty sure you have 2. All right, so I said to balance the equation, but how this might be written on yours, it might say, because remember it's multiple choice, so then it might say, what is the coefficient for H2O? Okay. And then it'll say, you know, A, B, C, D, and I'm just making this up. I don't know if any of these are gonna end up working out, but right, you would circle where your coefficient is. So regardless, you have to be able to balance, unless you want to take a guess, I guess. So to balance, I usually draw a line down where the arrow is. I list the elements in the same order on both sides. All right. Then I do my initial count. So on the left side, it looks like I have 3. All right, so that's 3. I have 8 for H. 1, 2, 3, 4, 5. 1, 2, 3. All right. 2 oxygens. Okay, on the right side, I have 2 hydrogens, 1 carbon, 3 oxygens, because I can't forget the one from H2O. All right. Got a couple, I have a couple initial thoughts here, and there are 2 things I tried to drill into your guys' head. One of them is we don't want an odd number of oxygens. It looks like no matter what coefficient I add over here on the right side to H2O, like I just don't want to get in the problem of having an odd number of oxygens. So I think I want to start there. Another thing is I'm starting to add coefficients on the right side and not the left, because I see that the left the right is lower tallies, right? Whenever I'm adding coefficients, I'm adding stuff, right? So I'm making those tallies bigger. So I don't want to start where it's already kind of large. So I'm thinking I guess if I want to make 8 hydrogens, I could put a 4 in front of this H2O. That will give me an even amount of hydrogens, as well as, I'm sorry, an even amount of oxygens on this H2O, right? As well as bring my hydrogens up to count. So now I have 4 plus 2, which is 6. Okay. All right. I could bring my oxygens up next, but I think since oxygen's by itself over here on the left, I'm thinking it makes more sense to even out the carbons first and then tackle the oxygens on the left last, because it's by itself. So it's when I manipulate it, and it's not going to change anything else. Okay. So we got 3 carbons. If I put a 3 here, that will give me 3 carbons, but it's also going to up my oxygen count. So 6 plus 4. So now I got a total of 10 oxygens. All right, so I can put a 5 in front of O2. That will be 5 times 2 will bring me to 10. And then I should be balanced. I guess this would have worked. We would have chose D. All right. So balancing, we don't need equation for. We didn't need to reference the sheet. Any questions? All
So
right.
you're saying for a question like that on the midterm, they might just ask like you said, like what is the coefficient for these
Uh-huh.
instead of or like will it require like
Yeah. So
like
there's two of them. There's one that's like, what's the coefficient? And then
okay,
there's another one where it says, is this equation already balanced? And then you say yes or no, and then so it gives one yes answer, and then it gives multiple no answers. And then if you say no, it says it proposes what's the correct answer. Does this make sense? It's like A, yes, B,
okay,
no, but it should be 2FE plus 3, right? Blah blah blah.
yeah,
C,
okay,
no, but it should be 1FE plus 2, blah, 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 right? It's obviously not yes. You got to figure out which no it is.
okay, okay.
Okay, 16. A nursing student has a sample of methane gas. So she has a fart, I guess. She or he has a fart. Okay. Containing 3.1 times 10 to the 19 molecules. How many moles are in this sample? All right. Whew. This takes us back. This might even be from lecture 1. And maybe not. Maybe it's still lecture 2. So we want to go from molecules to moles. Okay. Let's go to the reference sheet. So we're staying within the same compound. So we can still look at this sheet, the stoichiometry. We're just going to look at just one side of it, basically. So we want to go from, I know this says particles, right? But we can substitute the word molecules here. So we want to go from molecules to moles, all right? And this says that I'm going to use Na, which is Avogadro's number, which is that crazy number, and it's right here. 6.02 times 10 to the 23rd, okay? So we want to use I'm just gonna call Avo's number. All right, so I'm gonna start with what I'm given. 3.1 times 10 to the 19th molecules. And then, all right, so his number says 1 mole equals 6.02 times 10 to the 23rd stuff. We're gonna call it molecules in this case. All right, so I want molecules on bottom because I want them to cancel, which leaves me with moles on top. That crazy number goes with the molecules. So since I put molecules on bottom, I put that crazy number on bottom. All right. So that means I have to divide. All right. As we might have learned with the numbers with exponents in the pH unit, we got to make sure we use parentheses, right? I'm gonna write down here. So I'm going to type this in open parenthesis 3.1 times 10 to the 19 close parenthesis divided by open parenthesis 6.02 times 10 to the 23 close parenthesis. All right, this might be one where we have to change the calculator back. I'll just see what it gives me. I have mine currently in normal mode, so
So change it back to scientific.
yeah, yeah. All right. I got this. If you ever need help too, if you're like, I'm pretty sure I set this up right, just call me over and I'll tell you, yeah, you have the right answer, you just have it, we just need to change the mode or something like that.
Thank you.
Mhm.
Yep, I got that answer.
Perfect. Yay.
Wait, did you round?
I think so, yeah.
Because I did
I
five.
got
I got 5.14.
Yeah, I rounded, yeah.
I don't have to round on the test, right?
You
Or we don't
probably
know.
will. It'll be obvious. I mean, 5.4, like, choose the closest answer. It won't be, I think you'll be fine. You'll round. I'm pretty sure, yeah, you'll round a little, I think. I can't remember how many decimals, though. It's like 2 or 3. Okay, it looks like 2 more math-heavy problems. No, maybe 1 more. 2, 3. Oh, okay, I really lied here. We still got a lot to go. All right, 17. A student has 4 moles of C3H8. How many moles of hydrogen are in their sample? Okay, this is the one question I really don't like. I wish they would remove it because it looks like it might be a stoichiometry because you're going from one, you're switching compounds. You have moles of C3H8, and then all of a sudden you're going to just hydrogen, but there's no balanced equation. Okay. So this, I don't really have a formula for it. Well, we just have to interpret this molecule. So this molecule is saying that 1 mole of the entire compound is equal to whatever the subscripts are for each individual element. So, because there's a subscript of 3 here, it'd be 3 moles of carbon. And because there's a subscript of 8, it'd be 8 moles of hydrogen. All right. This is what's going to give us the information to solve. Okay. So I'm going to start with my given 4 moles of this entire compound. All right, now I want to get just moles of hydrogen. So I'm going to put moles of C3H8 on bottom and moles of just hydrogen on top. All right, so for every 1 mole, I'm getting that from right here, there's 8 moles of hydrogen. All right.
Do we still calculate in scientific or normal?
This would be normal.
Okay.
So for scientific, if you're working with numbers that have exponents, that's gonna be a Q. All right, so 4 times 8, 32. So there's 32 moles of hydrogen in this sample. All right, 18. I like 18, but it's also kind of like, why are we testing you on this if we're already going to test you on your ability to go from moles to grams in like a million different other problems? But it's fine. It's fine. All right, so we're going from grams to moles or vice versa here. So a student needs 0.45 moles of H2O. How many grams is this? All right, we're staying within the compound. There's no balanced equation, so this isn't stoichiometry. We're just going from grams to moles. We've done this plenty of times, so you should know we need the molar mass, and we need it to be unique to H2O. So we'll just go to the formula sheet. H2O is 18.1 here. All right, so 18.01 grams per mole. All right, so start with our given 0.45 moles of H2O. All right, we want moles of H2O on bottom because we want them to cancel, grams on top. This number is married to the grams, so since I put the grams on top, I'm going to put the 18.0 on top and the 1 mole on bottom. They're both on the top, so I'm going to multiply 0.45 times 18.01. Got 8.0 this.
Yep. Good job.
Thank you. All right, any questions on this page? I know that it looks like there's one more problem, but the information we need is on the next page. So I'm gonna scroll up in a minute once you guys tell me it's okay.
So you said to get the, like over on the side after you have grams per mole and the is 18.01. How did you get that again?
So I got it from the reference sheet.
On
I
the
mean,
reference sheet. Okay.
yeah,
Oh, okay.
really, I got it from adding together, the molar mass of 16 for oxygen and then what 1.00 for hydrogen. Well, but I don't. That's going to take time away from.
Mhm.
Right, so I just gave you some of them that you're going to need to know.
Okay, thank you.
Okay, I have a quick question. I
Yep.
think it's for number 15. So, when you put the 4 next to that hydrogen,
Mm-hmm.
that H2O, so
Mhm.
you multiplied the 4, but then you added, so you multiplied it and got
Mm-hmm.
8 for hydrogen,
Mm-hmm.
but then you added it for oxygen. Is that what you did?
Yes.
Because I remember okay, so why would we not, why are we multiplying for one and then adding for another?
Great question. I think I just probably worded it funny. So whenever we have a big number and then a small number, so like we have a number out front and then a subscript, you're multiplying those together, right? And then the same thing happens with the oxygen out here, but the subscript was an implied 1. So 4 times 1 was just 4. So then I probably said, oh, add 4 to the oxygen count because in my head I probably already did, 4 times 1. I probably just like
Oh
didn't
my
really.
gosh, can you for that little bit, can you repeat it? Because
Yeah,
something just happened
no, you're
to,
fine.
okay.
So when you have the big number and a small number, they get multiplied. Okay, so the 4 times 2 is 8, right? So then I wanted my total count for oxygens to be, or hydrogens to be 8. Okay, the 4 does also multiply with the implied 1 on this oxygen, but 4 times 1 is just 4, so I probably just said, oh, add 4 to the count because I was already doing 4 times 1 in my head.
Okay.
All right. Are you ready for 19?
Okay, yep, you can go ahead, 19.
Okay. So this got cut off. So also it's not pretty looking. It looks like this. Okay, so this I remember was for lecture 1. Um so we have um our nuclear symbol. This is what this was called. All right. And from our nuclear symbol we can determine protons, neutrons, and electrons. Okay. So we had the element symbol, then we had up in the top right was the charge. We had in the top left was the mass number, and then the bottom left was protons. Okay. So protons we can automatically copy. The number of protons is 35. They're going to tell me that in the nuclear symbol. The neutrons are a little bit hidden, all right? So neutrons are equal to protons plus neutrons equals the mass number. So we can take 80 minus 35 to get the number of neutrons. So 80 minus 35, I can do this in my head, 45? Okay. Now, if there was no charge, if there was no -1 here, that means it's neutral, so the number of protons would equal the number of electrons. But there is a charge. So the charge is -1. We can think of this a couple different ways. The first way is it has one, since it's minus, it must have more electrons than it does protons. So if it has one more electron than it does protons, 36. You only want to think that way after you've solidified the protons, or else you might accidentally subtract from the protons, and we don't want to do that because protons are what makes it Br, right? The other formula, charge equals P minus E. So if I knew my protons were 35, I knew my charge was -1. Can we move it down? Here, is that better? Then I needed 36 in order to make that work algebraically. All right.
I'm sorry, you lost me. Hold on. Can you say that again?
Electrons are just like all from the start.
It's the part where the charge equals P minus E.
Okay, yep. So charge equals P minus E. Okay, so it has a -1 charge. It's a -1. And then 35. And then this is like saying x algebraically, right? So to get x by itself, subtract 35 from each side. 35 minus 1 is -36 equals -x, but if I divide by minus for each side, I get x equals 36.
I got it. Thank you.
Yeah. All right, 20. All right, so there's going to be one problem where you have to calculate molar mass on your own. And whatever compound they give you, I'm not going to put that in the little table of reference values, okay? Because, they're testing you on your ability to calculate that. So it's not barium chloride, but it's something similar, something, along this lines. So if we wanted to calculate this, we need to go find the molecular weight of just barium and then just chlorine. We're going to times whatever we get for chlorine times 2 because we have a little number of 2 out here. And then we can add up what we get for the total molecular weight or molar mass. Those mean the same thing. All right, so I'm going to go to the periodic table. Wrong way. So chlorine, 35.45. Where's Ba? $137.3. Just circled the 3, but all right, so 137.3, 35.45, I'm pretty sure. Let me double check that. Yeah, 35.45. Okay. All right, so 35.45 times 2, 70.9. All right, so then I can add 70.9 times 137. I'm going to do this all without a calculator because I feel confident. But you could just type this into your calculator. Okay. Now I feel less confident. Let me double check myself. $208. Okay. So then you would, circle whatever molar mass you got. All right, 21. We're talking about temperature. So we're going to want to reference that formula sheet where we're going to want to reference the formulas for temperature. All right, so it says a temperature reading of 75.1 degrees is measured with a Fahrenheit thermometer. Okay, so they're telling me that this is Fahrenheit in a lot of different words, but okay. And we want to know if it was Kelvin. Okay. So we got to go from Fahrenheit to Kelvin. We don't have a direct formula for that. I'm sure if you Google it, I'm sure it exists. Maybe you want to Google it and you want to put that on your reference sheet. That's fine. But I'm going to give you Fahrenheit to Celsius and then Celsius to Kelvin. So if you weren't to Google whatever that formula is, this would be a two-stepper for you. All right, so I know Celsius to Kelvin is Kelvin equals Celsius plus 273. So I know that one. I gotta go reference what Fahrenheit to Celsius is. Fahrenheit to Celsius. All right. 5/9 F minus 32.
I got a question for 20.
Yeah.
Would BA always equals 137.3?
Yes.
Oh, okay. Just making sure.
On different periodic tables, it might be rounded ever so slightly different.
Okay, but as long as we know that we good, we
Yeah.
can get our answer.
Exactly. Yeah. Okay, so I copied the formula 5/9 F minus 32. Back after lecture 1, Sonia brought up a really good point to me about why don't I just change, well, she didn't say it like this, but why don't I just change the fractions to already decimals in the equation, because you have to do that already before you put it in your calculator. And I was like, oh, that's kind of smart. So I think I might change those to decimals before I have to make some edits to this document already. All right, so we got, what is our Fahrenheit? So I'm running out of room, but 0.55751 minus 32. So I got to do that before I times it by a half, or 0.55. So 75.1 minus 32 times 0.55. All right, whew, really messy here. Okay, I got 23.705. All right, so now I have my value I can plug in here. So I'm gonna just basically be adding it. I am adding it to 273. So I get 296, 7.705 Kelvin. All right, 22. So this is back from lecture 1, using density as a conversion factor. All right, I think I confused all of y'all when we did this problem the first time around. Hopefully now that we've done a lot of factor label, hopefully this will start to look a little bit better here. All right, we don't have a special formula for this, but I knew it was the density problem because it has the word density in it. So ethanol, also known as ethyl alcohol, has a density of 1.23 grams per mil at 25 degrees C. If 80.1 grams of ethanol is needed, what is the volume? All right, so here's our given. That first sentence, which is going to be written exactly like this on the test, just probably a different number, is our conversion factor. And we never want to start with a conversion factor, okay? We don't want to start with that 1.23. We want to start with the 80.1, okay? And we're trying to get to mils, all right? They give us information about temperature, but that's just because they are trying to throw us off. So what we really care about is this given density value. So 1.23 grams per mil, okay? So I'm trying to go from grams to mils, so I'm put grams on bottom, mils on top. This 1.23 goes along with the gram, so since I put gram on bottom, put that one on bottom. All right, so that left me dividing 80.1 divided by 1.23. No, not mils. I'm sorry, not grams, mils. Okay, any questions? We're getting there.
We started with 80.1 because it's bigger than the 1.23.
No. So the 1.23 is the conversion factor, okay? You never want to start with a conversion factor. You would
Okay.
probably, I would hope your mind would, if you accidentally tried to start with the 1.23, I hope your mind would go to, well, what do I put on top, grams or bottom, or mils? Because you're so used to manipulating that formula, right? So no, we didn't start with the 1.23 because it was the conversion factor. All right, 23, lovely old sig figs. I put a bunch of different identify the number, but again, remember your test is multiple choice, so it might just give you, one of these numbers and then it say A, B, C, or D answer choices, okay? But for the sake of practice, we can go through and identify. So remember that leading zeros never count, sandwich zeros always count, and the trailing is where it gets iffy. You want to be after a decimal and non-zero digit for it to count, okay? Or else it's just a placeholder. All right, so 2.001, those sandwiched are, yeah, those zeros are sandwiched, so they count. Was one of y'all gonna tell me it's
All
so
four numbers count.
yay, 4. All right, what about the next one?
3.
Beautiful, you know your sig figs. Okay, next one.
3.
4.
4.
4.
3.
3. Okay.
Why
I like
Oh,
3?
because it's not after a decimal, that last
It's,
zero.
yep, it's not after a decimal. There's no decimal there, so that's just
For
a
the
place.
0.
Yeah,
Okay.
the second zero. The first one is sandwiched and it counts.
Right. The last
All
one
right,
don't.
correct.
Okay.
I can't remember. Did we go over numbers with scientific notation at the end?
No.
This did
No.
not, that does not participate. All right, so we're just looking at the 1.201.
Well, that's 4.
4.
3.
4.
Because it's
Right?
the same zero.
Hmm?
It's
It's
a
same.
sandwich 0.
Sandwich zero, correct. All right,
That one was easy.
good, good. All right, yeah, I gotta scroll up a little, so if you have stuff you want to screenshot, do that now. If you don't mind, I'm gonna get myself a glass of water. Just 1 second.
Take your time.
All right, so I know we still have like a couple pages here, but it should start to go faster. We're through all the math heavy stuff. It should start to go a little bit faster here. Okay. So number 24, you have 4 questions where you need to write the names, or you might be given a name and you have to identify the compound. I did it compound to name for our practice because I think it's harder. So, might as well practice the harder method. And you'll have 4 questions, but I gave us more than 4 examples here, just because. Okay, so when we name, you need to be able to identify if it's a covalent or ionic compound. Okay, that's the first step because that's going to determine how you name, right? If we use the prefixes or not. So covalent is 2 nonmetals and it uses the prefixes. And then ionic is a metal and a nonmetal, those prefixes. Right? Both of them always, you're changing the ending of the second element to "ide." All right. So before we even try to name these, let's identify if they're ionic or covalent. All right. N2O. Is it ionic or covalent?
Covalent.
It is. CO.
Covalent.
CO2?
Oh no, it's iconic. Whatever.
No. No, it's a covalent. Everything's covalent so far. Hydrogen's the one weird one. He's a nonmetal, even though he's on the other side of the periodic table. So H2O2 is also covalent. Magnesium chloride, this is our first ionic. And then KCl is also ionic. Should we go into more detail of how we got there?
Yeah.
Okay. Let's go back to the periodic table. All right, so, oops. All right, so your yellows are metals and your greens are nonmetals. All right, so covalent is 2 nonmetals, so 2 greens. And then ionic would be a yellow and a green in this specific periodic table coloring. Every periodic table is a little different, but all right, so like CO, I know you were second guessing that one. So here's C and here's O. They're both nonmetals, so they're covalent. Hydrogen, he's still green. He just happens to be way over here. Hydrogen, oxygen, covalent. What other example did we have? We had nitrogen and oxygen, I think. Those are both green. And then we had, I know for sure, KCl. So Cl is green, but potassium is yellow. Was it MgCl? And
Yeah,
then,
MgCl2.
yeah, magnesium's also a metal, but then chlorine's still a nonmetal.
Yeah, got it.
Yep. All right, so we've identified if they're ionic or covalent, right? All right, so covalent is our first 4. They're going to use the prefixes. If you forgot, the prefixes will be here. All right, so 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa. So N2O6 is going to use the prefixes. So we got di, nitrogen, uh, hex, hexoxide. All right. The one thing with the prefixes is that we never put mono on the first element. We can put it on the second, but not the first. So this CO is carbon monoxide. CO2, carbon dioxide. H2O2, dihydrogen dioxide. Yep. All right. I personally like ionic because they're simpler. All right. We don't have to use any prefixes. We just have to keep the first element name the same and then change the second element's name to ide. So MgCl is just magnesium chloride.
All right.
What about KCl?
Calcium chloride.
There you go. All right, any questions about that? I guess I gave us one example where we go from formula. No, this is building it. Oh yeah, this is building. Okay. But sorry, 24. How do we feel about 24? Any other questions?
24 was pretty simple and easy. I like that one.
Good, because we got 4 questions over it, so
Okay.
that's good. I like to hear that. All right, so 25, building a ionic, well, they didn't tell you it's ionic, but building the chemical formula, all right? We only know how to do this for ionic. We could have done it for covalent, but like well, it wasn't in the scope of this class. So do you guys remember how we build it?
Start it off and then we can tell you.
Okay, we need to go to the periodic table. Do you
Okay.
know why? Do you remember why?
Oh, don't we gotta find all the like find CA, what's the number of that, and then
Yeah.
okay, I remember. I told you to start it off. See, look.
All right, so hopefully on your periodic table, you're gonna have all your trend lines and your numbers and stuff all written out. That's the goal. That's what I'm telling you to do, I guess. So we have +1, +2, +3,
Yeah.
±4, -3, -1, -2. That's going to be our charges for building an ionic compound. We also have our valence electrons, which just goes 1, 2, skip a few, 3, 4, 5, 6, 7, 8.
Hey,
Yep. Okay, we don't need the valence electrons yet. I just did it while we were here. We were building between what? Calcium and iodine?
yep.
Okay.
Mhm.
And then iodine, yep.
All right, so calcium's gonna have a +2 charge. Iodine gonna have a -1 charge. Okay.
Mhm.
All right, so +2, -1. Now I got their charges. Now what do I do?
Don't we gotta like add them or something?
Kind of.
Wait, don't we gotta like add like 13, 14? Wait, hold on, no, that may not be it.
No, yeah, now you've lost me.
Yeah, I lost myself.
They have
Okay,
to equal 8.
there you go.
Not quite. You're like, I get your thought process though. I get your thought process.
Wait, how did we know iodine had a -1 charge? Because the
From the
because I'm
periodic
looking
table.
at it, it's like mine say oh, okay, don't listen to me. I knew
I was gonna
that.
say it should say -1. If it says something different, let's make sure we change it. Okay, so we want to equal 0. We want it to be neutral. All right. So right now with 1 calcium and then 1 iodine, I have a +1 charge. Okay. So if I add another iodine, if I put a subscript of 2 here, that will get it neutral. The other trick is to swap the charges to be the subscripts or the tiny numbers. All right. Ones, we don't have to put ones in there. So calcium was going to take on the 1, but since we don't have to put ones, we just left it as calcium. And then I got 2 from the charge of calcium. If it's easier to do it the way I first did it, then just do it that way. All right, we'll keep going. So pH buffer, we just need to know what a pH buffer is. So it's a weak acid solution that resists major changes in pH. Right, so your discussion this week was about buffers. So we have our blood buffer, we have respiratory buffers, urine buffers, all that stuff. Buffers are pretty cool. They're complicated but cool. All right, 27. All right, 27 is kind of weird. I'm pretty sure I have a typo. I'm pretty sure I want C to say low OH. I know on your test it's not confusing. I just always forget to make this edit, and then I come back 8 weeks later and I go, what the heck was that edit supposed to be? Okay, so a pH of 8 is basic, right? A solution that is basic is going to have more OH than it does H plus. Okay, so it's going to have high numbers of this and low numbers of this. All right, not going to be D, not going to be A.
It's
A and
D.
C, yes. A and C are like saying the same thing, but they're opposite, right? But they would be describing an acid. These both would be describing an acid. All right. Yeah, that went over well. I'm glad. Usually I get myself all confused. Okay, 28. Particles that are too large to cross the membrane, colloids. You just have to identify that from a list of particles.
Yeah, that was from our discussion also.
Yep. That's this week's discussion post is like kind of the one good one, I feel like. I feel like it's good for coming up right before the test because it
Yeah.
deals with a lot of definition stuff. Yeah.
Yeah.
Just
That's what I was saying.
the one where they did okay.
Liquid's
Okay.
complete. Yeah. Solve it, solve it.
Soluble, is that what you're telling me?
Liquids completely dissolve in each other.
Okay, you just have your mic on. Okay.
Solve it. I thought it was solve.
Okay, so if 2 liquids completely dissolve in each other, how can we classify them? So 2 liquids, okay, so if we had a solid liquid solution, we would use the terms like soluble, insoluble. Ooh, I'm not soluble, insoluble. All right, liquid, liquid is the miscible, immiscible. Miscible, immiscible. So spelling. So miscible would be they completely dissolve, they're soluble. They're like each other. Miscible. I don't really know how to spell this. I'm pretty sure it's that though. Okay. 30. We got to identify the solute and the solvent. So the solvent is usually what's in excess. There's a lot of it. What's doing the dissolving. All right, so in this case, water is the solvent, and then the solute is usually a small amount. It's usually what's getting dissolved. All right, so here NaCl would be the solvent. No, solute. Okay, 31. This goes back to the beginning of lecture 1, solid, liquid, and gases. So we're figuring out which is which here in this definition. So A, an indefinite shape and a definite volume. So think about like the water bottle when I did my little analogy of pouring it out. Indefinite shape, right? If I pour it out, it's going to take on a different shape than when it was in the container, but none of it disappeared or anything. It has a definite volume. So A describes liquids. B, definite shape and definite volume,
Solid
solids,
and then gas.
and then gas. Yay, good. All right, looks like I have to scroll for the next one, so just take a second, ask for any questions, take any screenshots.
That one was easy.
Good. Yeah, I'm hoping the next page, I think the next page is the last page. Hopefully these are more just like definition stuff and they're easier.
Yeah, it's definitely easier than the math heavy stuff.
Yeah. All right. We good?
Yep, we're
Yeah.
good.
Okay. 32. Okay. So we just have to remember which side reactants are on. So it goes from reactants to products. All right, you have 2 questions where you want to know that. So like if we had A plus B yields C plus D, A and B are the reactants, C and D are the products. All right. 33. All right, exothermic. Exo, think of exit. So this is when heat is released. All right, if it's released, it's going to be on the product side. Endo, think in. So heat is required. So if we're looking at equation, this would be on the reactant side. So for this question, I should rewrite this practice question. So we have the one example I told you about in lecture where it says, oh, pick the example of the endothermic reaction. And it's got a bunch of examples, but the example you're looking for is glucose and water. Then I think that's all, actually. I don't know why I'm thinking about this too hard. I think you still see this, though, on the next test. I think that's what I'm getting myself tripped up about. But yeah, I'm pretty sure you see this again on the next test. The one thing. Okay, oxidation and reduction, right? I said we just need to know the definitions. I honed in on reduction here, so that must have been the one that's on the test. So reduction is gaining electrons, which is like the opposite of what the word sounds like. Reduction is gaining.
What was 32 again?
Oh, 32, you just need to know, like, you just need to know that reactants are on the left side of the arrow and that products are on the right side of the arrow. All right, 35, classifying reactions. You only have one, but I gave us like 5 examples because I love to be complicated, I guess. We could narrow this down to like 3. All right, so we have synthesis or combination. That's when you have A plus B and they start dating, so they become AB. We have decomposition. We have, so AB breaks up. We have single replacement, where one person's going to be single on each side. Double was the swingers. So AB plus CD, and then we go to AC plus BD. All right, so what does number 1 look like? At the beginning, lead is with chlorine, silver was with nitrate, then lead is with nitrate, and silver is with chlorine.
Are they
It could
swingers?
be double.
Yeah,
Yeah.
Swigger. Yep, the
Double
double.
bottom. Yeah.
Double.
It's class.
All right. 2, we got 2 things coming together to form 1.
So they
Synthesis.
Synthesis.
Synthesis. 3, we got Al with chlorine, we got sodium with sulfate, and then all of a sudden, say it again.
are they the swingers?
Yeah, so double.
Yes. Double.
Mhm.
Okay,
We
okay.
probably
okay.
should say that. We probably should say double instead of
Yeah, because you gotta know. It's not gonna. Swingers is not gonna be one of the answer choices.
they're gonna be
But it
like,
makes so
what?
much it makes so much sense.
It
It
do.
does. It's easier. It's so much
Look how we
easier to
remember
remember.
it.
Just remember that that goes with double replacement, though.
Right.
All right. Okay. 36 and 37, we've already built the foundation for. It's just going and checking the periodic table. So simple ion, that's when we do the +1, +2, +3 jazz. All right. So we actually already found it, didn't we? Because we had iodine earlier. Yeah, we did iodine earlier up here. All right, so it's -1, but like, you would go, whatever the element says, you'd go to the periodic table and just figure out what charge you're looking for, right? 37, this is where you're going to use the valence electron trend. All right, again, I already set the foundation, right? You're going to have your columns labeled 1, 2, 3, or sorry, 1, 2, skip a few, 3, 4, 5. All right, so magnesium, I honestly forget which column this is in.
It's 2 plus 2.
2. So we would choose 2. All right. 38 and 39. How many more questions we have? This is so painful. Okay. 9 has to do with the periodic trends, right? Which is another thing I want us to have written on our periodic tables. So
Are you gonna have a copy of the periodic table for us, or you want us to bring our own?
I'll have a copy. They'll just be in black and white and they won't be written on already.
No, I'm gonna bring my own.
Yeah. All right. So we have the arrows this way is ionization energy. And then our other trend was the opposite. I'm gonna put him in green. And this is atomic size, also known as atomic radius. All right, so the first question, oh, no, I clicked on the same thing. First question, how does the trend work? I don't know if this is the exact wording of this one, but they want you to choose the answer that says increasing as you go to the right and up, right? Because that's how we drew our arrows on our periodic table, right? All right, size though, this one they actually make you order them. So here we want increasing order, so we want to go from small to big, right? And the trend for this one is the opposite. If this was a periodic table, we'll go back to the periodic table though. So we have Cl, Br, F, and At. So Cl, Br, F, and then At. Oh, this is nice. They're all in a line. Okay. So we increase as we go down, right? So it's gonna be smallest fluorine, then chlorine, Br, and then At, right? Fluorine, chlorine, bromine, At. All right, we're getting there. All right, characteristics of metals. All right, so they're good conductors of heat and electricity. Good. They're malleable. You can make them into things. Non-metals are the opposite. They're poor conductors of heat and electricity. And they're not malleable because they're usually gases at room temp. Not all of them, but usually. Metals are usually solids at room temp. Again, not all, but usually. (41), which element is located in period 4, group 12? All right, so like I said, you know, sorry, were you gonna
Is
answer?
it zinc? Yeah,
Period 4, group 12.
zinc.
It
Is
is
it?
zinc. It
Okay.
is zinc. Perfect. Okay, what I was gonna say though, I liked this periodic table because it distinguishes between the periods and the groups where some don't. So if you are going to print out your own, just that might be something you want to look for, that it just tells you which ones is which, right?
Or can you just post yours and
Yeah,
we
I can.
print it out?
Yep.
Thank you.
I'll put that with my post reference and periodic table. Okay, I'll do that after this. The recording of this will take me a while because it takes forever to upload. Zoom was way faster when I did Zoom recordings, but they want me to use Teams. Okay, 42. What's the decimal number? This is not an exact test question. I just want us to make sure we know. This is the molar mass, or the what are all our different names? I already forget. Molar mass. Oh, molecular weight. Um, Molar mass, molecular weight. Yeah, I think I just wanted you to know that these mean the same thing. Okay, before I scroll on to the next page, any questions? Let's see if we can get all this page into view here.
Okay, got it.
Cool. All right, 3 more, right? Bless.
How many questions in total for the midterm?
50.
Okay.
So, and like, so I basically given us every question. I know it says 45, but remember some of them are duplicates, right? Like naming ionic and covalent compounds.
Okay.
All right, so solution versus compound versus matter versus mass element. So I'm just gonna quickly go over these. So, the solution, it was a homogeneous mixture um, of a liquid and a solid or two liquids. I think the key part here is homogeneous mixture. If you see that, you should be able to identify compound, right? This is two or more elements together. Right, so for example, H2O, right? I'm going to jump to element, right? An element, right? That's just a single thing, right? You find it on the periodic table. I'm gonna call him single guy on PET, periodic table. So for example, just hydrogen, right? That's kind of messy. Let me erase this. Matter, anything that takes up mass and space. Uh, Element we just did, mass. Oh, why am I blanking on the definition for mass? It's kind of like weight, but without gravity. The amount of space something takes up. I think that's the technical definition.
A measurement of the amount of matter in an object is the actual.
Amount of matter. Perfect, thank you. We'll delete this then. The amount of. So I think technically this is the only one that's a test question where you have to know identify the definition. But these are words that I just wanted to review because they're on the test at some point, right? I just want to make sure we just know them. Yeah. All right. Let's again, you only have one question about physical and chemical properties, but might as well do a couple. So physical properties, this was things like color, odor, state of matter, right? If something was a solid, liquid, or gas. Um, Size, appearance, stuff like that. And then chemical, like I tell my middle schoolers, it's all the things that end in like Y. That's what I tell them. But like flammability, solubility, um, reactivity, reactivity, flammability. Wait, we already did that. Flammability, solubility, reactivity, solubility, that kind of stuff. I think that should help. That should get us where we need to be. All right, 45. This takes us all the way back to lecture 1. when we were describing things. So we had to describe it two ways. We had to describe the number of molecules it had within the compound, and then basically their composition, like were they all the same or not, right? So when our numbers, we were monoatomic, di, tri, or poly. And then the composition, if they're all the same or not, right? We said it's either homoatomic or heteroatomic, all right? So CO2 is going to be triatomic because there's one carbon and two hydrogens, so there's three total. And then it's not all just carbon, it's not all just hydrogen, so it's triatomic, heteroatomic. Hetero meaning opposites, right? And then alike or same. All right, we did it. Questions? All right, so I'll post the formula sheet once I make those few edits that I, got pointed out to myself.
Thank
And
you.
then the periodic table, but the recording for this, I would not expect that tonight because the last week's took me like 2 hours for it to upload.
That's all right.
Yeah, I mean you're here to the very end, so it's probably not like you guys are thinking too hard about that part.
Are you doing like a small review tomorrow or no?
No, this was the review. On Tuesday though, I'll be there probably like 4:30, and Thursday for the other group.
Okay, and we can come in early.
Yeah, you can ask questions and stuff.
Okay, sounds good.
Yeah.
Thank you.
Yep.
Yeah.
Thank
Thank you
you.
for doing this.
Thank you.
Yep.